everyone. We're going to go over this Punnett square worksheet together. Hopefully this helps you all understand how to fill out Punnett squares number 1, how to understand what dominant and recessive traits are number 2, and also what genotypes and phenotypes are, because that's what these Punnett squares help us understand. So, to get into our scenario, it says black is the dominant fur color for rabbits and white is the recessive. Okay? This capital B stands for the black allele, and the lowercase b represents the white allele. A white rabbit would then have the genotype of both lowercase b's, which would be homozygous for the recessive trait. A black rabbit would have the genotypes of either both capital B's, which is a homozygous dominant, and then they could also have the genotype of an uppercase B and a lowercase b, which would be heterozygous. Okay, so hopefully that helps you out to start off with. Let's go to these Punnett squares. I'm going to fill out 5 of these with you guys. So to start this one, we have a cross between 2 homozygous dominant parents. Okay, so we take this capital B and this goes in both of the columns here. So we'll start right here. This capital B goes here. Okay, lets me put a text box in there. Here we go. Okay. So we got a capital B in there from this parent, and then we will also get a capital B from this parent. Okay. Same thing here. We will have a capital B from this parent and a capital B from this parent. And if you didn't guess by now, there would be a capital B here from this parent and a capital B there. And here as well. Alright? So when you're crossing 2 parents that are both homozygous dominant, you're going to have all the dominant alleles here. So that means these parents would only have rabbits that have black fur because they only have the black fur allele. Okay? Let's skip over to number 2. Alright, so we have both heterozygous parents here. So we take this dominant allele, and that goes in this box. We got this dominant allele, that goes in this box, okay? However, when we get to this box, we get the dominant allele from this parent, but we get the recessive allele from this parent. So that means this would be a heterozygous genotype. Then here we get the dominant allele from this parent and the recessive allele from this parent. So that is another heterozygous. Okay? And then in this box, we get both lowercase. You see how I get that is I have the lowercase or recessive allele here, and they both meet up in this box. Okay? So these parents would have 3 of their children with black fur, and then 1 potentially with white fur, which means these 3 all have the phenotype of black fur. This one has the phenotype of white fur. However, they only have 2 potentially that would be heterozygous, okay? So those 2 are heterozygous pairs. These 2 are both homozygous. This one's homozygous dominant. This one is homozygous recessive. Okay, let's jump down to number 4 here. I think you guys hopefully are getting the hang of this. I know sometimes these can be tricky, but if you see we have 1 homozygous dominant parent and 1 heterozygous parent. So let's see what we would get from them. We would have 1 dominant allele here and 1 dominant allele here. Then if we go down in the column, we would get the dominant allele from this parent and the recessive allele from this parent. We go here, once again, we have the dominant allele from this parent and the dominant allele from this parent. And down here we get the dominant allele from this parent and the recessive allele here. So when these 2 cross, it means all of their children will have black fur, so they would all have the phenotype of black fur. Remember, phenotype is the characteristic that is expressed. However, half of their offspring potentially would be heterozygous, and the other half potentially would be homozygous dominant. Okay, they wouldn't be able to have any homozygous recessive because they only have 1 of the parents with the recessive allele. You see how that works. Okay, let's jump over to number 5 here. So it looks like we have 1 parent that is homozygous recessive and 1 that is, again, heterozygous. So if we're looking at this one, we get the dominant allele from this parent and we get the recessive allele from this parent. And if we jump over here, just over in the column, once again, we get the dominant allele from here, the recessive allele from here. Now if we go down, we will be getting the recessive allele from this parent and this parent. And then jump over in the column, we get both, again, recessive alleles. So, as you can see, this is now has potentially half of the children from this cross would have black fur, the phenotype, remember? However, they would be heterozygous genotypes. And then the other half would have white fur, but their genotypes would be this homozygous recessive. Okay, So we know that they're homozygous, recessive, or dominant if they have two of the same alleles. Okay? And we know that they're heterozygous if they have two different alleles for the same gene. Okay. Hopefully you guys are following along so far. We're going to do one more. If you look at crosses 8 and 9, we have to figure out what the parents are based on what these offspring are in the Punnett squares. So the easiest way to do this, actually we'll do number 8, is to see what is the same across here. Okay? So we know that there is a capital B here and a capital B here. So we could say potentially this is a genotype of, or an allele of the dominant, okay, the dominant allele. Same. Now if we go across here, if I take out this dominant allele, and this one, we know that going across here, we need to have a recessive allele, okay? Because if this one's the dominant, this one needs to be the recessive. Alright, so we got our dominant going down, our recessive going across. Now, same this way. I already have this recessive allele taken care of, so what I need is to have the dominant allele going down. Okay? So if I have the dominant allele going down, that means once again I need the recessive allele to go across to make it match up. Right? So that means I crossed one parent that was homozygous dominant genotype. That means they had the dominant genotype here, both dominant alleles, and then this one was homozygous recessive. So heterozygous dominant or homozygous dominant, homozygous recessive. Now when we cross these, that means all of the children will have black fur. However, all of their genotypes will be heterozygous because they received one dominant allele from one parent and one recessive allele from another parent. Awesome, awesome. Okay, so I went over 5 of these with you. You need to do the last 4 on here. And you also need to choose two of these last 4 to solve, okay? And if you decide to do all of them, I will give you, oh sorry, 2 of the last 5 of them. If you decide to do all of them, I will give you 1 point extra credit for doing all of the questions. Okay? If you guys have questions, please feel free to contact me. Hopefully this video helps you out. I know some of you had struggled with understanding what genotypes and what phenotypes you get from these crosses, but hopefully this helps you out. Okay, so remember, this is asking the probability of having black fur, which would be the phenotype for cross 1. I'll just let you know the probability would be 100% there, okay, because all of them would have black fur.